Welcome back, everyone. So in this video, we're going to talk about a trigonometry lesson, which is the sum and difference identities. Without further ado, let's begin. Before we proceed to know all of the formula, okay, let me rewrite all of these special angles. We know that the main special angles are 30, 45, and 60. Am I right? I would like also to include the angles in the axis, right? Because they say that these are also special angles. Okay, so let's rewrite the other slide. 120, 135. Okay, we have 150, 180. Okay, 210, 225, 240, 270, 300, 315, 330, and 360 degrees, right? And so on and so forth. Okay, these are all the what the coterminal angles. Okay, coterminal angles for each of these special angles. So you see, okay, they are called special angles because they can give you the exact value, and it is also simplified. It's like simplified yet exact. So these are the possible values or answers that will come up to you, like positive or negative 1/2, positive or negative square root of 2 over 2, positive or negative square root of 3 over 2, okay, positive or negative 1, 0, positive or negative square root of 3, and last but not the least, positive or negative square root of 3 over 3. Okay, so for example, if I were asked to find what is cosine 135 degrees, cosine 135 degrees is negative square root of 2 over 2, which is one of the possible answers. Next is, what if I am asked to find tangent 60 degrees? Tangent 60 degrees is positive square root of 3 over 3. Now see? So you see, they can give you what? The simplified yet exact value. Okay, instead of using calculator. Because if you're going to use calculator, for example, I will use negative square root of 2 over 2. This would result into negative 0.707 and so on and so forth. Or what they do is that they just approximate it into two decimal places into negative 0.71. So much better if we're going to use this term. It may seem irrational, but this is the simplified effect. All right. So I'll give you two scenarios. All right. So hold on. Let's just say I have tangent 60 degrees. I can actually rewrite this one into tangent of 30 degrees plus 30 degrees. Or maybe I could do it into, tangent of 90 degrees minus 30 degrees. Okay, could be. How about if I use sine 300, 300 degrees? And I could rewrite this one as sine of 150 degrees plus 150 degrees. Yeah, could be. So what can we say in these first two examples? These first two examples, as you can see, on the left part of the equation, you have the trigonometric function, and then you have your input, which is a special angle. Same thing goes on here. You have a trigonometric function, and then your input is also a special angle. So this on the right side, you separate this one whose special angle into two different special angles or the same angles, just like this one, 30 and 30, and the different ones, 90 and 30. So you see, these are all also special angles, especially this one. Okay, how about to the other one? So how about if your input is not special angle, just like 75 degrees, right? And then we have sine of 345 degrees. These are not special angles, okay? So this one, however, I can rewrite this into two separable special angles, which is 30 degrees and 45 degrees, because 45 plus 30 is 75 degrees. And we also can do this here, which is 300 degrees plus 45 degrees. So you see, okay, this one, all right, this is not a special angle, especially on the second example, all right? But if we're going to separate them both, these are all what? Special angles, then 30, 45, 345. So what can we say on this four examples? Okay, and why do I give them a boundary for each of these two? Because on the left side, your input here is what? Is a special angle. While on the other hand, it is not a special angle. So that's their main difference. However, the similarities between the two is that they can be separated, meaning that the special angle they use on the left side of the equation, they can be separated into two separable special angles. All right. So this one right here, we're going to use what? Another method, which is sum and difference identities. All right. So also guys, I would like also to, let's just say, draw a graph. I would like also to draw a graph. I would form two angles. All right, two angles. Okay. So let's just say I have the whole angle here, the whole angle here. Okay. This one, again, you knew that this is 90 degrees, right? 90 degrees. Okay. And then I have the other angle. I would form it here. I will form it here. Hold on. That's it. This is 45 degrees. Okay. So if we're going to use, let's just say sine, okay, a trigonometric function, which is sine. If I'm going to use sine 90 degrees, obviously this is 1. If I use sine 45 degrees, obviously this is what? This is basically square root of 2 over 2. Okay. But I want also, also to know, like, what if I had a given, I want to know this angle, 90 minus 45 degrees. I want to know the value of what? Of, hold on, sine of 90 minus 45 degrees. 90 degrees minus 45 degrees. Okay? See? You get the point here? You see my point here, guys? Okay? So this part right here, okay, I know this is just a easy way. If you're just going to subtract them, this is just sine 45. And then the answer for that is square root of 2 over 2, which is, yeah, it is easy, right? But what if I told you, the whole, the sum or the difference of a particular special angle is not a special angle? What if I told you that? All right, what if? Okay, like what if? Okay, so imagine, okay, I will use different, what do you call this one? Different angle form. Okay, so imagine this one. I have 45 degrees. And then right here, okay, oh, wait. No. Let me use different color. Okay, wait. Yellow, that's it. So right here, example, I have 30 degrees, okay? And I want to know, the whole value of it, you know, okay, like, you know, 30 degrees plus 45 degrees, okay, which is equals to 75 degrees. So what is sine of 75 degrees? Okay, or to write it in different way, what is sine of 30 degrees plus 45 degrees? Okay, so now we're going to use a specific formula. Okay, so if we have sine as your given and you have a and B as the two special angles, or basically any angles that you like to, let's just say add or subtract. So the formula for that would be sine A times cosine B plus cosine A times sine B. If, however, I have two angles, whether it's special or not, okay, and I subtract them both to get the difference, then it's still the same. All right, the terms used are just the same. However, the difference is that the operation used would be subtraction. Okay, that's it. How about if it's cosine? Cosine, okay, A plus B. So the formula for that would be cosine A times cosine B minus sine A times sine B. All right. Then the other, cosine of A minus B. Okay. This would be like, again, just copy the terms. Oops, wait. This seems wrong. It's like co raised to 5. Okay, that's it. So cosine A times cosine B plus sine A then sine B. Then last but not the least are the tangent. So there's two actually. So if you're going to add them two, so you'll have tangent A plus tangent B all over 1 minus tangent A times tangent B. Okay. And last but not the least, which is, yeah, I just already said earlier, which is what if you're going to subtract two angles? So just interchange the operations. Okay, this would be tangent A minus tangent B all over 1 plus tangent A times tangent B. Okay, so these are the formulas, okay, in sum and difference identities. Be careful on using this one, okay? You can use it anytime, anywhere, okay, as long as the answer would be correct, right? So overall, these are the, once again, formula. So the next video is we're going to answer, some questions. Basically, this is just a, a practice video, which I am going to upload, next day. All right. So once again, thank you everyone for listening. And here, Math Angel Grade will always guide you in answering mathematics. See you.